Hello everyone. So the next type of problem is analyze the continuous beam ABCD shown in figure by slope deflection method and draw bending moment diagram. So they've only asked you to draw the bending moment diagram here. All right. So this is the given beam and A is fixed. B, C and D are having the roller supports. So you can see here there are three spans, 1, 2 and 3. Okay, and all the spans have same I values here. So it is a combination of all three types of loading here. So AB is a span. AB is a span wherein there is a UDL acting of 30 kN meter and having a span 4 meter. Then BC is a span which is having a load, that is concentrated load at the center, that is 60 kilonewton, and CD has a load of 60 kilonewton, but this is eccentric load. This is eccentric load. Okay, so these are the three spans. So the different thing about the previous problem was in this span, all the previous problems were only two span, but this time it is a three span beam. Okay, and so again the steps and all are same. So that is, first is the fixed end, finding the fixed end moments. Next is finding the slope deflection equation, and third one is finding the equilibrium equations, and the last one is final moments. Okay, all right. So again, just by seeing the problem, you can analyze whether the just seeing the problem, you can analyze whether the rotations exist or no. Okay, all right, you can see here. Just a moment. Okay, this is a fixed support. So fixed support, there is no rotation. So theta A would be 0. Whereas these are all hinge support, that is B, C and D. They are hinge support. Because they are hinge support, there exists the theta values. That means there exists theta B, theta C and theta D in the given beam. Okay. All right. So there would be now three unknowns here. You have to find all the three unknowns. That is three rotations, 1, 2 and 3. Okay. So let us start with the first step, that is first fixed end moments. To find the fixed end moments, first is MFAB. Okay, MFAB is equal to, AB is a UDL. So because it is a UDL, the formula would be WL square by 8. Sorry, WL square by 12. So because it's the first point, left side joint, so MFAB is minus WL square by 12. So put the values, substitute the values here in the formula, and then you'll get minus 40 kilonewton meter. Likewise, MFBA. So MFBA is same, B to A. So B to A, again, right side support. So it will have positive sign in it. So it is now WL square by 12. Substitute the value here. So 40 kilonewton meter. Next, BC. MFBC, this is a single point load, and the point load is actually acting exactly the center. So the formula is WL by 8. So because it's the first joint, minus WL by 8. Okay, it's minus 30 kilonewton meter. MFCB is plus WL by 8. So plus WL by 8. Okay, so after this, MFCB calculate, so it is plus WL by 8. And the final fixed end moments. Now here it is eccentric. Now because it is eccentric here, so this would be, the formula would be MFCD. MFC to D is minus. So because the left support, so it is minus W A B square by L square. Okay. So C is, so when you try to find out this, so it is like when you start measuring from C to D, so the first thing is, because left support, it has positive sign, a negative sign as in this portion. Then this is A and this is B. So A means the nearer support, B means the farther support. So A is 2 into farther support is B square, that is 4 square divided by 6 square. So it is now WAB square by L square. So it is minus 53.33. Similarly, MFDC is again nearer support is B, farer support is A. So W A square B by L square. Again, sign is positive. So substitute the values, then you'll get this answer. Okay, be careful with the signs. So whenever it is eccentric, both the moments will not be same. Okay, all right. So the next step is slope deflection equation. So again, slope deflection equation, MAB first. So AB span MAB is equal to, formula remains same, MFAB plus 2EI by L into, open the bracket because the first term is A. So it is 2 times A plus theta B minus 3 delta by L. Again, there is no sinking of support, nothing. So this term would be equal to 0. And this would be, again, you can see here theta A. A is a fixed support. So fixed support, the rotation, that is theta is 0. All right, then MFAB is equal to, you have already calculated this, MFAB is minus 40, so it is minus 40, 2EI, I remains I only, divided by L, length we have already given, that is 4, and because both the terms are 0 here, it becomes 0, so this is theta B, so I left it only theta B, so now this becomes minus 40.5 EI theta B, so this is equation number 1. Then similarly, MBA, so MBA, the formula is MFBA plus 2EI by L. Then open the bracket. Again, as usual, write it in sequence. First theta A, then theta B. So theta A plus, now the B term is first here. So B term is first, so it should be multiplied with 2. So 2 times theta B minus 3 delta by L. Close the bracket. So again, theta A is a fixed support, so it becomes 0 and there is no sinking of support. In the question, they have not at all given the supports are sinking. So this term also becomes 0. So you're left with only theta B now. So it is minus 40 plus 2EI by L into theta B. So when you substitute this, so minus 40 plus 0.5 EI theta B. Okay. Okay. So now this becomes, 2 EI by L. This, both the terms become 0. And so plus 40 plus 2 EI by L. So it has 2 in it. So multiply. So it is only theta, EI theta B. So this is equation number 2. Likewise, find equation number 3. So MBC is equal to MFBC plus 2 EI by L 2 times theta B. Again, B is the first term. So 2 times theta B plus theta C minus 3 delta by L. Okay, now you can see here theta B and theta C both are roller supports. So they did not become, there is rotation. Only if there is a fixed support, only then theta value becomes 0. Now, but because B and C are roller supports, there exists theta values. Okay, so this is now, because B is the first term, so it is 2 times theta B plus theta C minus 3 delta by L. So MFBC already calculated. So minus 30 plus, again, EI, I value is same here, I only. So it is 2 EI by 4, 2 times theta B plus theta C. Okay, so minus 30 EI theta B. Again, when you multiply this here, so it is 0.5 EI theta C. So equation number 3. Similarly, calculate MCB. So MCB is equal to MFCB plus 2 EI by L. Then first, as usual, write the sequence. Theta B first, theta C next. But theta C is the first term here. So you have to multiply it with 2 times. So theta B plus 2 theta C minus 3 delta by L. Again, this becomes 0. But it's actually very important to write this formula also. Okay, then you equate it to 0. So you're left with 30 plus 2 EI by 4 theta B plus 2 theta C. So 30 plus 0.5 EI theta B, EI theta C. So equation number 4. Then MCD. So MCD is, again, the formula is MFCD plus 2 EI by L 2 times theta C. Okay, so theta C is first here. So theta C plus theta D minus 3 delta by L. So again you can see here theta C and theta D. Theta C and theta D are having the roller support. So roller support means they will rotate. So because they will rotate here, there exists theta values. Okay, so this is now theta C. So 2 times theta C plus theta D. So it is MCD is equal to minus 53.33 plus, again, 2 2s are 4. So 4 by 6 is 0.67 EI theta C Again 2 by 6, that is 0.33 EI theta D. Okay. Next, MDC is equal to MFDC plus 2 EI by L. Okay. Again, let it be in the sequence only, theta C and theta D. But here, theta D is the first term here. So multiply 2 with that. So minus 3 delta by L. So again, 3 delta by L is 0. Theta C and theta D will exist because there exists a roller support. So again, substitute these values here and then you will get MDC. So MDC is now equal to 26.67 plus, okay, 1 by 3, so 0.33, 4 by 6, 0.67. So this is sixth equation. Okay, so we have got 6 equations here. Now after this is we have to calculate the equilibrium equations. So in equilibrium equations, equilibrium equations should be found out wherever there exist two joints or wherever there is a roller support. Okay, now you can see here. Okay, first it's a fixed support. So fixed support, there is no rotation happening. So leave the support. Then next at B, it connects two members, and in addition to this, there exists rotation. So it is MBA plus MBC is equal to 0. That would be the first equilibrium joint. Next, second equilibrium equation would be MCB plus MCD is equal to 0. That is second equation. And the third one we are taking here is MDC is equal to 0. Now, why we are taking this is because at D there is a roller support, and this roller support will have rotation in it. Now, because it has rotation in it, so that's why we'll take the equation as MDC is equal to 0. There is no other connecting member here, but we'll be considering this, but not fixed support. So now you should know why we are not taking fixed support and why we are taking roller support. The fixed support is because there is no rotation happening. So rotation and all are stopped. Now because they are stopped, so theta value becomes 0 here. But whereas in roller support, it bends like this. That means rotation means it bends like this portion. So that's why it exists. So MDC would be 0 here. So these are the three equations we'll be taking and we'll be solving now. Okay, so first equation is moment about B is equal to 0. So moment about B is there are two members connecting the joint, that is MBA and MBC, and that equates to 0. So MBA and MBC we have already calculated in the equation. So MBA, choose the MBA is equation 2 plus equation 3. So that is what I've written here. And when you're writing this equation, be careful with the negative sign also. Okay, so write both the equations equal to 0. Again, keep it in the simplified and in the sequential form. And that would be theta B plus theta C should be equal to a constant. Okay, so it is 2 EI theta B plus 0.5 EI theta C. So here it is plus 10. So when it goes to the right hand side, it becomes minus 10. Okay, so now write it as equation number 7. So again, why I've written 7 is because to maintain the continuity. Okay, 6 we have already completed here. So this is equation 7 now. Likewise, calculate moment at C. Now moment at C, again it connects two joints. Moment at C connects two joints. MCB plus MCD is equal to 0. So moment at C. So equation number 4 and equation, see here, equation number 4, equation number 5. You have to add both of these. So equation number 4. Okay, when the equations are very long, so what you have to do is write this. Either you can write in terms of bracket and then you can open the bracket. Okay, so I've written here equation number 4 and equation number 5. Okay, so write both of this. Then again, let this be in the sequential form only. So always it is theta B, theta C and theta D. Okay, keep the thetas first. Of course, again, theta A will not exist because it's a fixed support. So now in that cases, first I'll write the theta B values. So theta B, again, there is a reason why we write it like this. That's because when you solve this in the Cal C, when you solve and find the values of theta B and theta C, you do it in the Cal C. So when you're doing in the Cal C, the first term would give you theta B, the second term would give you theta C, and the third term, the third unknown value would give you theta D. That's why it's very important to write it in the sequential form. All right, so now this would be EI theta B, this first one. Okay, there is theta B here also. There is only one theta B here, so we'll write this here. The theta C value, you can see here, EI theta C is 1 here. And there is one more here, EI theta C, 0.67 EI theta C. So you have to add both of this. Okay, so you can just mark it like this. So in that case, when you add both of these, there should be 1.67 EI theta C. Okay, then plus, so there is one more term here, 0.33 EI theta D. Okay, then 30 minus 53. So it is minus 23.33 when it goes to the right hand side. So when it goes to the right hand side, it becomes plus. Okay, so now this is the resolved form and in equation form. So that is equation number 8. Okay, then the last equation is MD. Now again, why you're taking this joint D is because joint D has roller support and it will rotate. So that's why we're finding the rotation here, that is theta D. Okay, so MDC is equal to 0. So MDC is the sixth equation. Only you have to take the sixth equation. So write the sixth equation and equal to 0. So again, keep it in. This is as theta C and theta D. So keep it as it is, 0.33 EI theta C plus 0.67 EI theta D. Okay, again this minus plus 26, when it goes to the right hand side, it becomes minus. Okay, all these signs are very, very important because these are the signs which will be putting it in the calci and finding it out. Okay, so now what I've done here is I've used the matrix method to solve this, and this is a manual method, okay, which I've solved here. But I'm going to tell you an easy method which you can do it in the calci. Okay, so it's better. All the three equations, that is 7, 8, and 9, solve it in the calci. Okay, we have already done this in the previous type of problem, but that time there were two unknowns. The same procedure we are going to use, and we'll be solving using three equations. Okay, now again, use the calci, take the calci, and in that press the button mode 3 times. When you press the button mode 3 times, so you'll get the equations here. So choose the equation 1, choose the first option, equation 1, and once you choose the equation 1, then there will be the unknowns there. So unknowns 2 and 3. Okay, now we have 3 unknowns here. Now the 3 unknowns are theta B, theta C, and theta D. Okay, so 3 unknowns. So press 3 there. Okay, press 3. Then it will ask you A1, A2, A3, A1, A2, A3, B1, B2, B3, and C1, C2, C3. So, but it will appear in terms of equation. So, the first term would be A1, B1, C1, and this would be D1. Okay. So, put it in the calci first. Theta B is the first term. Okay. Theta B is the first term. So, put it in the calci and then find out. Okay. So, A1 is 2, B1 0.5. Okay, C1, actually according to us, the third unknown is D, but here we don't have theta D. So C1 would be 0. Next, D1 is minus 10. Okay, then press again equal to, then it is next second equation, that is A2. A2 is 0.5, B2 is 1.67. Now here you have the C2 value. So C2 is 0.33. All right, and D2 is 23.33. Similarly, next, the third equation, again press equal to, again you'll come back to the third equation, that is A3. So A3 is 0.33. Okay, now see here, A3 according to us is the theta B value, but we don't have theta B here. So what we'll do here, A3 is 0. Next, second term is theta C. So B3 is 0.33 and C3 is 0.67 and D3 is minus 26.67. So we got all three equations, then press equal to. Okay, so once you press equal to, directly you'll get the values, and that too you'll get it in terms of sequence. That is theta B, theta C, and theta D with the signs, and always be careful with the signs. So now directly when you press in the calci, you'll get the sign. So EI theta B is minus 12.095. EI theta C, again press equal to, so you'll get EI theta C is 28.38, and next EI theta D is minus 53.7. So be very careful with the signs, because one sign changes. Suppose if you take one mistake, if you do one mistake in this equation, so you end up getting the different answers altogether here in the EI theta values. Okay, so once you find out these values, the next thing is you have to substitute in the final moments, the last one. The final moments would be, again, substitute ei theta b, ei theta c, and ei theta d in the above equations. So when you substitute here, so it is MAB first. So first slope deflection equation is MAB. So MAB is nothing but, it is putting all the three values in the first equation, which we have already calculated here. First equation number 1. Okay. So it has only ei theta b values. So it is minus 40 plus 0.5. Instead of ei theta b, be careful with the sign also. You have to also consider the sign. So it is minus 12.095. So it is minus 46.04. Okay. Similarly, MBA, again, substitute all the values in equation number 2. Slope deflection equation number 2. So it is plus 40 plus, again, so it is only ei theta b. So substitute the value, you'll get this. Next, MBC. So MBC minus 30 plus, it has both here, ei theta b value as well as ei theta c value. So substitute both of this and then you'll get minus. Okay. Now the check here, but like whatever you have done is right or no. So the final check is whatever you have taken here, MBA and MBC. Okay, you have taken equilibrium joint. That is the third equation. That is moment about B is equal to 0. That is MBA and MBC should be, when you add both of these, when you add both the moments, it should be 0. Now you can see here 27.905. So this is plus and this is minus. When you add this, it should be 0. That means at both the joints, the moment should be equal and opposite. So when they are equal and opposite, the signs, okay, the sign are equal and opposite. The magnitude is equal, sign is opposite. So this term becomes 0. Okay, so what you have found out is right. Similarly, MCB. Okay, now see here, MCB, again substitute all the values here and you'll get this. Okay, now at joint C, it connects CB also, it connects CD also. So CD, again, substitute the value here of CD. So this is C and this is D with the sign. So it is minus 52.33. Okay, now the check here is MCB and MCD. The magnitude is same, but the value is different. Magnitude is same, but the sign is different. So this is plus 52, this is minus 52. So when you add both of this, it becomes 0. Okay. Next, finally, MDC. Again, we have taken that MDC, the value should be equal to 0. So again, put all the values. So MDC is 0. Okay. So moment cannot exist at the simply support. So we already know that moment at the simply support end, that is, or at the hinge support, or at the roller support, or at the fixed hinged support, roller support, or simply support, the moment will be 0. Okay, so once you find all these moments, the next step is drawing the bending moment diagram. Okay, so in bending moment diagram, what we'll do here is, as usual, we'll go on finding out the free bending moment. Okay, so free bending moment is bending moment diagram. So for span AB, BC, CD, so we'll first draw the bending moment. So span AB is a UDL. So UDL formula is WL square by 8. Okay, substitute the values. So this is 60. Next, for span BC, so span BC, the free bending moment is WL by 4. Okay, because it is exactly concentrically loaded. That means exactly at the center there is a load. So it is WL by 4. So we have substituted the values here, WL by 4. Next, finally, for span CD, it is eccentrically loaded. Now, because it is eccentrically loaded, it is WAB by L. Okay, so WA is 2, B is 4 divided by L. So this is 80 kilonewton meter. So now this is the free bending moment. Okay, now because it is a free bending moment, exactly at the center, first draw these free bending moment. Okay, first it is 60, then again it's also 60 for point load at the center, and finally eccentric is 80. Just draw this triangle. Okay, because it is a UDL, parabolic, point load, triangle, eccentric load, triangle. Okay, once you draw this, again try to draw this to a scale. Now because this is 60, this is also 60, it is same on the same line, but 80 is little higher side, so draw it little on a higher side as such. Okay, then the next thing is you have to draw the fixed bending moments. That is what you have calculated here. Bending moment is support. So MAB is minus 46. Again, show it here. Okay, always this will exist above only. See, plus and minus, we'll be drawing the bending moment diagram on the same side. But later when we hatch this, there we are going to distinguish between what is positive and what is negative. Okay, so exactly at A, it is 46. Okay, minus sign. So draw it on the straight above A only. Then at B, it is, see here, at B, it is plus 27 also, minus 27 also. So what I'm going to show here is, I'm going to show here only. Okay, on the, exactly on B, the magnitude is same. So 27.90. Okay, next, similarly at C, it is 52. Both are same, 52.33. So above C, I'm going to show it as 52.33. Okay, I'll show it on minus like this. Okay, and finally at D, it is 0. So D, I'll just point it out like this. Okay, now you have to draw the bending moment. You have to show this like this. So it is exactly at A, it is 46. So draw a straight line here. Then at B, it is little less. So that is 27. So again, 60 is higher, 46 should be little lower. And of course, 27 is much more lower. So just mark this point here, less. Okay, then join these 2 points, connect it. Then again, 52, it's little higher. Okay, greater than 46. Just show it greater than 46 here. Then join this. And finally at D, it is 0. So mark this like this at D. Okay, so now wherever there is space as such, be above the point here A, and go on marking this, just hatch this like this, these are all negative bending moments. So negative bending moments will occur at the support, exactly at the support, whereas positive bending moment will occur under the loads. So these are the loads, so all these are okay. So when you draw this like this, so whatever is above this line, whatever is above this, you can see here, whatever is above this line, fixed end bending moments, all those bending moments are positive. So I've hatched it here and showed it as positive. So here also it is above this line, so it is positive. Above this line, positive. Okay, so all these are positive bending moments. All right, below this, okay, whatever are below this, and only, and check out, always the negative bending moments will occur only at the joints, above the joints, above A, above B, above C, okay, and at D. So only about the joints there exists negative bending moments, and above this negative bending moment diagram exists the positive bending moment. Okay, all right. So this is how we draw the bending moment diagram for the continuous beam using slope deflection equation. Okay, that's all for today. Thank you.